Solving systems of linear inequalities is very similar to what we did when we were just trying to graph the solution of a single linear inequality. So first, we're doing the same thing. We aren't going to find individual numeric solutions like we could with equations. What we're aiming to do is to graph the region that represents the infinitely many points that are the solution to the system. Right, so to do that, I'm literally going to treat this like it was two separate problems. First, I'm going to graph the solution to the first inequality. Then I'm going to graph the solution to the second inequality. And ultimately, what I'm looking for is the overlap. Right, the area where the two solutions overlap will be the solution of the system. Those are all the points to satisfy the first one and the second one. All right, so let's see how we can do this. Remember the process. I'm going to start by making this into an equation. 2x plus 3y equals 6. And I want to graph this because that's going to be my boundary line. All right, so what am I going to do? Let's solve this for y. 3y equals minus 2x plus 6. Then divide by 3. Y equals negative 2/3 x plus 2. All right, so I'm going to go here to 2. That's the y-intercept. And negative 2/3. That's down 2 over 3. And I'm going to do this several times in both directions to get a bunch of reference points on here. Try to make my final line here look nice. So if I draw, what kind of a line am I drawing? This is strictly greater than here. So I'm going to draw a dashed line. And I'm going to get my first boundary. Right, now remember, the next step, I'm going to choose a test point. I'll use the origin here. Right, so kind of just focus on where that is. So if I put that in here, I get 2 times 0 plus 3 times 0 is greater than 6. Left side is 0. That's why I like picking the origin for my test point. 0 is not greater than 6. That is not a true statement. So the origin is not a solution, and neither are any of the other points on that side. My solution is all of the points on the other side. Now, if you've got multiple colors, if you've got, I've had students with, bringing colored pencils, colored markers. That works. Or you can do what I'm doing here. I'm doing one set of lines horizontal. I'll do the other set of lines vertical, and anywhere you get the complete grid, right, is going to be the final solution. All right, so now let's do this one. It's going to be the same thing, right? I'm going to make x minus 2y equals 4. And I have to graph this, so I'm going to do minus 2y equals minus x plus 4. And y is equal to positive 1/2 x minus 2. So minus 2 is down here. And the slope is 1/2, so I'm going to go up 1 over 2. I'm going to do that several times. There we go. And I want a solid line here because this is less than or equal. So I'll do a solid line through those points. Not too bad. There we go. And I should have put arrows here too, shouldn't I? Oops. Should have put arrows on the ends of both lines. There we go. And I'll use the origin again, right? No reason not to. So I'll let that be my test point here. If I put that into the inequality, 0 minus 2 times 0 less than or equal to 4. Left side again is 0. And that is true. 0 is less than or equal to 4. So the solution to this inequality, the solutions, will be everything on the origin side. So it's everything over here above and to the left. So I'm going to shade all of this up here. You notice getting this crosshatch region in here. Now here's where you have to be careful. It's easy to lose track of the line you're supposed to be following and accidentally start following the other. So I'm really focused on the solid line. That's the one I'm going over to every time. There we go. And now you can see your solution. It's this region here above the dashed line and above the green line over here, the solid line, that area is my solution. In other words, right, what does this really mean? All of the points that satisfy both the first inequality and the second inequality are in that region that's kind of above both of the two boundary lines.